Hello, everyone. Welcome to the talk. My name is Chen. I'm a tech lead of the MLKit team at Google. I'm here today to talk about MLKit, Google's machine learning SDK for mobile. I will provide an overview of what MLKit does, and also what's new since its inception 6 months ago. I also share some tips and the best practices to improve performance, accuracy, reduce size, and a few other things. In the end, I will talk about what we're working on. 2 years ago, Google CEO Sundar Pichai said, we'll move from mobile-first to AI-first world. The intersection of these two worlds means machine learning on mobile. In recent years, more and more mobile apps are using machine learning to produce fascinating user experiences. With smartphones becoming increasingly powerful and capable, more and more machine learning logic is shifting from the server running in the cloud to the mobile device in your pocket. Running on-device machine learning has many advantages. It's fast, it does not need to send very expensive RPC costs and incur long network latency. It also runs anytime, anywhere, with and without network connectivity. It also provides better protection for user privacy, since the data does not have to leave the device. Let me take a quick poll here. How many of you traveled from outside California to attend this Dev Summit? Wow, welcome. Welcome to the Silicon Valley. I hope you get a chance to visit Golden Gate Bridge, Fisherman's Wharf, and also enjoy some good food at a local restaurant around the Bay Area. Talking about food, my biological watch tells me it's time for dinner. So where should I eat? Well, I will pull out my phone, ask Google Assistant, hi, Google, I'm hungry. Any good restaurant around here? Google Assistant uses machine learning to understand my question and make recommendation where to go for dinner around the area and location I'm currently at. When I travel to a new place, I would like to take a lot of photos. And Google Photos use image recognition to understand image content. It can classify photos quickly into thousands of categories. It can also detect individual faces, paths, objects, text in the photo, and then make them searchable by keywords or categories later on. Mobile device can now run really increasingly sophisticated machine learning tasks. Last spring, I took my family to Tuscany in Italy. We drove around those beautiful hilltop towns. In each of the towns, there are many signs, but I don't speak Italian, unfortunately. I wish I do. So how do I know what it means? Here's where the Google Translate came to rescue. Google Translate can perform multiple machine learning tasks in a single journey. When I pull out my phone, pointing the camera at the sign, it will use optical character recognition to detect the text in the sign. It will also use natural language processing to translate the text from one language into another. Finally, it will use speech synthesis to convert text into voice, and using speaker to tell me what the sign is in my own language. All these tasks involve machine learning. Combined, they produce a seamless and a powerful user experience. These all look great, but as a developer, how do I build something like this? Well, it's doable, but not easy. Machine learning often requires specialized knowledge and years of experience in training and building ML models. The model training, a lot of time, requires a large amount of good, high-quality data. The mobile device, however, on the other side, it has very limited computing power. The models running on a server in the cloud are often too large or too complex to run directly on the mobile device. You need to spend a lot of effort to optimize the model for the mobile usage. After finally the app is built, you need to worry about how do I deploy, how do I maintain ongoing experimentation of the models. That becomes another headache. To tackle all these problems, we launched MLKit, Google's machine learning SDK for mobile, which helps mobile developers to build Android and iOS apps using machine learning technologies. MLKit is aimed at making machine learning easy for mobile developers. Just because you want to use machine learning on mobile, it does not mean you need to worry about collecting data, building models, training, model compression, optimization, hosting, deployment, downloading model, all this headache. MLKit will take care of all this for you. We provide common turnkey models that work just out of the box. All the models are optimized for speed, accuracy, as well as efficiency for the mobile device. We provide one consistent API across both Android and iOS. It's very easy to integrate MLKit with Firebase tools like remote config or A/B testing. For commonly needed machine learning tasks, we have base APIs that come with pre-trained Google models that work out of the box. Currently, there are 5 APIs we are supporting. The text recognition API are supported on both on-device and the cloud. The on-device API can recognize Latin characters, and the cloud API support a wide range of languages and special characters. Face detection is another API we support, which can be used to detect faces in both static image as well as live video streaming. Now, we also launched contour detection, which can help you to identify different parts of the face, and you can then apply face masks or filters. The barcode scanning can be used to detect both one-dimensional and two-dimensional barcodes, as well as a QR code. Image labeling API can detect objects or various entities inside the photo. It supports both on-device and the cloud. The on-device API supports more than 400 labels, which cover most of the common things you see in photos, while the cloud API can support 10,000 labels across many categories. Finally, our landmark API can recognize well-known places in the photo, like White House or Eiffel Tower. If this pre-trained model do not fit your need, and you are an experienced developer with knowledge in how to build and train models, you're more than welcome to bring your own custom model. We run custom models on TensorFlow Lite. As you might know, TensorFlow is an open source framework for machine learning. And TensorFlow Lite is a lightweight version of TensorFlow optimized for mobile platforms. For models trained with TensorFlow, we provide you tools to convert and compress into a format compatible with TensorFlow Lite. When you're using custom model, you have 2 options: either bundle it inside your app or host it in the cloud. If you choose the latter option to host in the cloud, it does not mean you need to build your own cloud server. MLKit and Firebase will provide a way for you. We will manage the model hosting, deployment, downloading, upgrade, as well as the ongoing experimentations. Since MLKit was launched 6 months ago at Google I/O, we have made several enhancements. First, we greatly enhanced our face detection models, which is now 18 times faster and 13 to 24% more accurate. We also polished our text recognition API by making them more streamlined and consistent across both on-device and the cloud. In addition, we launched 133-point face contour detection. As shown in this image, you can see now you can use our face contour detection API to identify the contours of various parts of your face or anyone's face in the photo, and includes the entire face, both eyebrows, eyes, nose, and lips. This is where the real-time apps can put custom face masks and filters, like a goggle or some funny nose on the face, and make the mask move with the face in a live video streaming. Next, I'm going to share some tips and best practices for how to use MLKit so that I can build impressive mobile apps using on-device machine learning. First of all, I will share a couple of tips for achieving best accuracy. There are 2 things you should make sure. One, you should take a very sharp and a well-focused image. Poor image focus can really hurt the accuracy. Second, you should ensure the object you want to detect in the image has sufficient size. For example, for face detection, you should have at least 100 by 100 pixels for each face. And if you want the contour detection in a selfie mode, for example, then the face should be 200 by 200 pixels. For the text API, for Latin languages, each character should be at least 16 by 16 in size. And if you use our cloud API to detect and recognize Chinese, Japanese, and Korean, then each character in those Oriental language should be at least 24 by 24. Similarly, barcode also have the size requirement. Please check out our online documentation for more details. Machine learning and the libraries can be large, which can slow down the app download. There are two ways to reduce the APK size. First, you can build your app as an Android app bundle. By doing that, you enable Google Play to automatically generate APKs for specific screen density, CPU architecture, as well as the languages. Then your user only have to download the APKs and native code libraries that match their device configuration. Another way you can reduce APK size is if the machine learning feature in your app is not the primary purpose, then you could move the machine learning features which require the ML kit into a dynamic feature module. In that way, you prevent users from unnecessarily downloading ML models, which can sometimes be large. We all know machine learning involves a lot of computation, so the speed becomes really important. Here are some tips how you could improve the performance, especially for real-time inference on streaming video. You can reduce the image resolution as well as the video frame rate to limit the amount of computation it involves to do the inference. When the current frame is being processed, you should also throttle incoming video frames to avoid any backup, which increase memory as well as slow down the performance. For real-time face detection, you should use fast mode, which luckily is the default mode. Oftentimes, 480 by 360 resolution is sufficient for face detection. For real-time processing, you should also choose between contour detection versus classification or landmark detection, but not both, because doing both could be expensive and may not be fit for the real-time processing in the slow device. Another tip and trick you can use is you should wait for detection to finish before render the face and contour together. You can check out our online Quick Start sample app on GitHub for more details. To illustrate what I mean, I will do a live demo. Let's switch to the demo mode. So for the purpose of demo, I'm using a slower 3-year-old Nexus 5X phone, because using the latest Pixel phone, the differences are not as prominent. In the first video, I'm going to show you without any performance tips. And we do not do video throttling. We do not do any lake drawing to make sure the contour and the face are together. So if you just call the API without any performance improvement, you can see the contours are not following the face. And there's a big gap between these two. All right? So now I'm going to switch to another version after applying performance tips. In this version, it's using the exact same Nexus 5X phone, but we throttle the incoming video frame when we're still processing the current frame. And also, we wait for the detection to finish before render both the face and the contour. As you can see now, the contours are following the face all the time. They match each other. There's no more gap. Cool. So let's switch back to the slides. Thank you. If you're using our custom model API, how to include the model becomes something you should consider. There are two ways. You can either bundle the model inside your app or host it on the cloud. If you bundle your model in your app, It's available immediately. It also does not require any model downloading, so it works offline. But the downside is you get a bigger app because the app contains the model. It may slow down the app download. Also, you cannot change the model without a new app release. On the other hand, if you host a model in the cloud, we provide all the hosting support for you. You get a smaller app size because the app itself does not contain the model, which translates into faster installation. You also can choose to download model only if it's needed. The model updates can come over the air into the app without any new app release. You can also use remote config and the A/B testing framework provided by the Firebase to do phased rollout as well as controlled pilots. The drawback of hosting model on the cloud is, obviously, it needs connectivity. When there's no connectivity, you cannot download the model. Also, the model will not be available until they're downloaded. So a third option is using a hybrid approach. You can bundle the model, the initial version of the model in the app, so make it usable right away after installation. Then you can receive model updates over the air from the cloud. If you're using our base API, it's provided in two different forms. For the latter of better terms, I call it thick SDK and thin SDK. In the thin SDK, the model is actually provided by the Google Play service, which means they're shared across all apps. The apps itself does not have to contain the model, and which will make your app smaller. Text recognition and the barcode scanning APIs are provided through the thin SDK. The second type is called thick SDKs. The models are bundled inside the SDK. Each app will have their own copy of the model, which will increase the app size. Face detection and image labeling are supported through the thick SDKs. To use this two type of SDK and use various APIs provided by the ML kit, you need to include the appropriate ML kit dependencies in your app-level build.gradle file. Inside that file, inside this dependency section, if you want to use the API support through the thin SDK, you should add the dependency called Firebase-ML-Vision. And in addition, if you want to use thick SDK, you should still keep this line because all the Vision API entry points are coming from this thin SDK dependency. But you also need to add additional dependencies. For example, if you want to use image recognition, image detection, then you need to add the Firebase ML Vision face model dependency because it's a thick SDK. Similarly, for image labeling, if you need that feature, then you need to add image label model dependency. Next, I will talk about a few new areas we're currently working on. A few new ML-Kit features are either under development or in early testing phase. We expanded beyond vision, starting natural language processing with Smart Reply. Smart Reply is a feature which can enable you to produce meaningful response based on the current conversation context. We're also planning to go into other areas like speech. At the same time, we will continue to enhance performance and accuracy of base APIs. We launched model compression and conversion service to our alpha users, which help them to convert and compress large model into smaller and faster versions for mobile usage. The conversion service currently is in alpha, uses pruning, quantization, distillation, as well as transfer learning to retrain the large models, make them smaller and faster without sacrificing too much accuracy. Fishbrain is a community-based app. It enables users to share the photos of their catch and within their social networks. With a machine learning model, it can identify any fish with just a photo. When they first came to us, their model is more than 80 megabytes. By using our conversion and compression service, they're able to trim down the model to under 1 meg. As you can see, they not only maintain same level of accuracy, it's actually slightly better. If you're interested in trying out our model compression service, please join our alpha program by signing up today at g.co/firebase/signup. No matter you are new to machine learning or experienced AI expert, I hope you enjoyed the talk today and can take home some tips. And I can't wait to see what you will build with MLKit. If you have any question, I will wait outside in the Ask Andre lounge. And we'll also have office hour tomorrow. Thank you very much for listening.